Hello to all my AP Chem students. We are going to start a little overview of chapters 7 through 10, and I know that might seem really daunting, but there's a lot of things that you've already learned on here. So what I'm going to do here in these videos is, these are my notes for the note packet. I'm just going to highlight a few things. There's going to be some things that are new that we haven't talked about, so we'll have some outside videos or some discussion time to talk about some of these. So the first thing you see here is your blank periodic chart. I will have that on Schoology, so you can take a look at mine and make sure that yours looks similar. And remember, as usual, if you have any questions on any of those terms, make sure you bring them to my attention. All right, Coulomb's law is something that you probably can understand pretty easily, but probably wasn't used in Chem 1 in terms of this definition. You probably heard of ZEF, or effective nuclear charge. AP Chem wants us to use Coulomb's law, so they will be changing that format for students moving forward. But for you guys, it's used to predict the amount of energy required to remove electrons, which we know is the ionization energy. So if I can highlight just a few items here, the formula that we have here is going to be taking a look at Coulomb's law and the force between them. So we can see here that the force is proportional to Q1 times Q2 over the distance, or the radius squared. And as I have here, Q1 and Q2 are charged particles. So I hope you're thinking protons and electrons are the charged particles. And then the distance between them would be our nucleus, from the nucleus to the energy levels, and that would be that distance. So we can see, if we're taking a look at this formula, that it's proportional to the magnitude. And remember, magnitude is just size. And so that should make sense to you that it's proportional because they're both on the top. So we have a force, or the amount of energy required to remove an electron, is the higher the charge is, the greater the force is going to be. And then it's inversely proportional to the distance. So you can see my force here is on the top, my distance is on the bottom. That should be an inverse proportion. And that should play a part that if you think about going down a family, you're going from 1s, 2s, 3s, 4s. And so those are those energy levels. The distance is going to be greater, easier to remove those electrons. So the particles that I was talking about, you can see that if it's positive, that would be a proton. If it's negative, that would be an electron. Of course, they're going to have an attraction between the two. The greater that attraction is, the greater the force. So one proton, one electron versus two protons and two electrons. Greater attraction, greater forces. And then if I'm comparing electrons that are paired, or maybe at different energy levels, they're going to repulse each other. If I'm taking a look at the number of protons that are there, again, they are going to not be attracted to each other. That's why we have neutrons in the nucleus, so we don't have that unstable situation. But again, they are going to repel. So this is Coulomb's law. We just take an account to use this to help us explain ionization energy, and it's all based on the atomic radii. So here's the next question that I have here. It says, which of the following, oops, sorry, I still have this on pen. Which of the following systems have, I should probably move over here, sorry about that. Which of the following have a larger ionization energy, and explain your reasoning? Now, an electron, distance d, so just some sort of distance from the nucleus, and a particle, it should say, with a charge of +2. And then we have that same distance with a particle with a charge of +1. You're not ever going to be asked to really calculate these, but you can see that I put in the charges there. And if you just simply do some math where the distance is the same, you can see that the force, and the one that I have circled, is going to have the greater force, greater charge, and so higher ionization energy, meaning that it's going to be harder to remove that electron. And the reason that's going to be harder to remove is because there's probably going to be more protons. Now, I did write on there electrons are closer to the nucleus, and that is because of the charge and the loss of electrons that are there. But if we really just think about the number of protons that are there, they're going to be more attracted to that electron. Then I have the atomic radii of bromine are larger than atomic radii of fluorine. Now, you probably in Chem level 1 would just have talked about that. It's further down the family, there's more energy levels. Well, we just have to be a little more specific here in the AP level. So you can see, again, I just started looking at that I have the difference in protons, the difference in electrons. You can see the electron configurations that I wrote there. And so for that, you can see that I have, let's see, let me grab, oh, I still have the highlighter on. So you can see that I have the highest energy level 4. Here I have the highest energy level of 2. So again, that's going to play a part in the atomic radii, in the atomic structure of it. So I just talked about that bromine has more protons and electrons, so that means it has more energy levels further away from the nucleus. So in terms of Coulomb's law, that's an inverse relationship, and so it's going to have lower forces, easier to remove electrons, larger atomic radii. Okay, so I think I'm going to stop there in terms of this first video, and then the next one is going to be a review of electron configurations, which I have some of that here, but I will step back and show you again what that means. I hope you guys are all doing well.